Example 5.4. We have 6 resistors in the circuit. It's a combination circuit. You can see R4 and R3 are connected in series. Their combination is in parallel with R1, and that combination is in series with R5, R6, and R2, right? Yeah, they're connected across a 50 volt battery. The question is to find the current flowing through R2 and R3. Let's find the equivalent resistance of this circuit. R3 and R4 are in series. So R3 and R4 are in series. But their combination is in parallel with R1, right? And that combination is in series with R5, R6, and R2. Okay, so let's start from here, R3 and R4. They're connected in series, so their equivalent resistance R34 should be equal to R3 plus R4. That is 2 plus 4, 6 ohms. So you can replace R3 and R4 with a single resistor of 6 ohms. Now their combination is in parallel with R1. So I'm replacing R3 and R4 with R34, that is 6 ohms. It is connected in parallel with R1, right? Everything else is the same. R1 is 6 ohms. So how do you find the equivalent resistance of these 3 resistors now? They're connected in parallel, so 1 over R134, that is equal to 1 over R1 plus 1 over R34. 1 over R134 is equal to R1 is 6, 1 over 6 plus 1 over 6. 1 over R134 equals 2 over 6. Flip it, R134 equals 6 by 2, that is 3 ohms. So we can replace all these 3 resistors with a single 3 ohm resistor. Just like this, we can replace all these resistors with a single 3 ohm resistor. The circuit would behave the same. Okay, I'm going to draw that. Replacing R1, R3, and R4 with a single resistor of 3 ohms. R134, that is 3 ohms. Yeah, just replace 3 resistors when everything else is the same. R5, R6, and R2 connected across a 50 volt battery. R5, R6, and R2, right? This is our circuit now. Yeah, now all of them are connected in series. So R1, 2, 3, 4, 5, 6, which is the equivalent resistance. How do you find that? R134 plus R5 plus R6 plus R2. R134 is 3, R5 is 1, R6 is 3, and R2 is 2. Nine ohms. That means we can replace all these resistors, all the 6 resistors, and just connect a 9 ohm resistor, and the circuit would be the same. I'm going to draw that circuit. Just replaced all the resistors with a single resistor Req, that is 9 ohms, that is connected across 50 volt battery and 9 ohm resistor. I equals V over Req. V is 50, Req equals 9. So 50 over 9, 5.55 amps. 5.55 amps would be flowing through the battery. The same current would be flowing through R2. The same current would be flowing through R6. The same current would be flowing through R5 as well. Because they're connected in series, the current should be the same. 5.55, 5.55, 5.55, 5.55. So how do you find the voltage drop across R2? We got the answer for the first one, right? Current flowing through R2 is 5.5 amps. The same current that is flowing through the battery. Now, how do you find the voltage drop across R2? This V2. What is V2? Again, Ohm's law. V2 should be equal to I current flowing through resistor 2, that is I times R2. What is I? 5.5. What is R2? 2. 11 volts. There is a voltage drop of 11 volts here. That is V2. Let's say V6 is the voltage drop across R6. V6. How do you find V6? V6 equals same equation, I times resistor 6. I is 5.5. They're all the same. R6, resistance of resistor 6, R6, that is 3 ohms. 3. So 5.5 times 3, 16.5 volt. What about voltage drop across R5? Let's call it V5. Current is 5.5 times 1. V5 equals I times R5. Current is 5.5. Resistance is 1 ohms, so 5.5 volt. So V5 is 5.5 volt. Now we need to find the voltage drop across R1. R1, R3 and R4, right? They're connected in parallel, so we need to use Kirchhoff's voltage rule. Consider a loop. Let's say this loop. Okay. Battery is providing 50 volts, right? So that is plus 50 here, plus 50. And there is a voltage drop of minus 11 here, minus 11 across R2. There is a voltage drop of 16.5. It is minus 16.5 here. That's a voltage drop here. And a voltage drop of 5.5. 5.5 volt minus 5.5. How do you find the voltage drop across R1? Yeah, we can use Kirchhoff's voltage rule. Let's write that equation. Battery is providing 50 volts, so plus 50 minus, there is a voltage drop of 11 here. It's a drop, so minus 11. A voltage drop of 16.5 here, so minus 16.5. So voltage drop of minus voltage drop of 5.5 here, minus 5.5. So voltage drop of V1 here, we don't know what is V1, right? We are going to find that. That's the voltage drop across R1. So minus V1. That's a complete loop now, right? This is my loop. Starting from the battery, R1, this is my loop. So voltage drop across R2 is 11, voltage drop across R6 is 16.5, voltage drop across R5 is 5.5, and voltage drop across R1 is unknown, let's call it V1. Battery is providing 50 volts. So plus 50 minus 11 minus 16.5 minus 5.5 minus V1 should be equal to 0. Kirchhoff's voltage rule. Let's find V1. V1 equals, take V1 to the right side, 50 minus 11 minus 16.5 minus 5.5. 17 volts. So we have a voltage drop of 17 volts across R1. R1 is connected in parallel with R34, right? So if we connect a voltmeter here, it is V34. It will show a reading of 17 volts. the same voltage as V1 because they are connected in parallel, right? Yeah. We have the voltage drop across R1. So how do you find the current flowing through R1? This is a junction, right? And 5.5 amps is coming towards the junction. So current I1 is flowing through R1. We don't know what is I1. And I34 is flowing through resistor R3 and R4. So how do you find I1? We can use Ohm's law. I equals V over R. We are finding I1, so voltage drop across resistor 1 over resistor 1. That is 17 over 6. 17 over 6, 2.83 amps. 5.5 amps is current coming towards the junction, and 2.83 is flowing through R1. The remaining should be flowing through R3 and R4, junction rule, right? Total current entering the junction should be equal to total current leaving the junction. So 5.5 amps is coming to the junction. How do you write the equation? 5.5 amps is coming towards the junction. I1 and I34 are leaving. That is 2.83 and I34 are leaving. 2.83 plus I34. So what is I34 then? 5.5 minus 2.83. 2.67 amps. So 5.5 amps current is entering this junction, and 2.83 amps is flowing through R1. The remaining 2.67 is flowing through R4 and R3. So we got the current here. That is 2.67 amps. If you need to find the voltage across R4, now you can use V equals IR. We know the current, that is 2.67 times 4. You'll get the voltage drop here. This V4. If you want to find the voltage drop across R3, that is V3. Current is 2.67 times 2.